This video lecture is meant to cover the information found in Unit 14 on solutions and equilibrium, specifically covering objectives 3 and 4. We're going to be talking about different ways to express the concentration of a solution, which there are lots of ways that we can do it. There's going to be two that we focus on primarily, and one of those two will be the one that will be our main way of expressing concentration. The two most prevalent ways that we will express concentration is molarity, which is the moles of solute divided by the liters of solution, and the percent by mass, which is expressed as a percentage as the mass of the solute divided by the mass of the entire solution. So this right here, in this example, the 2% butterfat, the 2% milk, what we have here is the mass of the solute, in this case 77 grams of butterfat, divided by the mass of the solution, and in this case the mass of the milk itself. And so 3,810 grams of milk in a gallon. Of that 3,810 grams of milk, 77 grams of that is butterfat. So if you divide those two numbers and multiply by 100, you get percent by mass, because those two numbers are, of course, in grams. Now there are a couple of other ways to express concentration. Instead of doing a percent by mass, you would have a percent by volume, where you would have the volume of the solute divided by the volume of the solution, and then of course multiplied by 100. An example here, rubbing alcohol, if you go to the drugstore, you can get it either in a 70% or a 90% concentration. The 70% has 700 milliliters of alcohol in a total of 1,000 milliliters of solution. 90% rubbing alcohol has 900 milliliters of alcohol within the 1,000 milliliters total of solution. Parts per million is really just counting the particles of interest, the solute particles, the number of solute particles, per the total number of particles in the entire container. So, for example, if you had $10,000 worth of pennies, 1 penny would be 1 in a million pennies. And so that's to give you an idea of 1 ppm, 1 part per million, is 1 penny out of $10,000 worth of pennies. $10,000 worth of pennies is a million pennies. The number of minutes in 2 years is a million minutes approximately. So 1 minute out of that 2 years is considered to be 1 part per million. If you had a 1 mile high stack of pennies and 1 dime in that stack of pennies, the 1 mile high stack of pennies would be about a million pennies, and the 1 dime would represent 1 part per million. So part per million is really just counting 1 particle out of a total of a million particles. So if you had 10 parts per million, that of course would be 10 particles out of a million. So parts per million is based on a count of the particle in question based on the total number of particles present. Then there's another way to express concentration that you will sometimes see in chemistry classes called molarity. We're going to just touch on it here, but we're not going to spend a whole lot of time on it in class. But molarity is the moles of solute divided by the kilograms of solvent. And so this is different from molarity. Molarity is moles of solute divided by liters of solution. So the difference here is that the denominator of molarity has to do with just the mass of the solvent separate from the quantity of solute that's present. So these are just some other ways to express concentration, and as long as you're aware that these exist, and there's other ways to express concentration, that's where we're going to leave it. So we're going to spend a little bit more time talking about how to do these problems for both percent by mass and molarity. First example, percent by mass being the mass of the solute divided by the mass of the solution times 100. Okay, let's look at this first problem. 10.8 grams of sodium chlorate is dissolved in 85 grams of water. Determine the percent by mass of sodium chlorate in this solution. All right. Well, 10.8 grams of sodium chlorate is the solute. 85.0 grams of water is the solvent. Okay, so what you need to recognize here is that the solution is the solute plus the solvent together. And so if you, of course, take a look at the mass of the solute being 10.8 grams and the solvent being 85.0 grams, adding that up together, you get 95.8 grams, and that is the mass of the solution. So that's what's going to go into our denominator. So the mass of the solute, 10.8 grams, divided by the mass of the solution, which we've just determined to be 95.8 grams. Okay, grams will cancel. We're going to multiply that by 100, and if you do this in your calculator, you get 11.2734864%. Of course, that's way too many significant figures. If we go back and take a look at all of our measurements, they all have 3 significant figures, so this becomes 11.3% of sodium chlorate in the solution. All right, I'm going to go ahead and have you skip number 2 for the moment. Flip your page over and let's take a look at problem number 3, which is another percent by mass problem. How do I know it's a percent by mass? Well, if we read this problem, it says calculate the mass of NaCl required to produce 900 grams of a brine solution that has a 15.0% by mass concentration. That little tidbit tells me that this is a percent by mass problem. Okay, so we know the percent by mass is the mass of the solute divided by the mass of the solution. We are given the percent already to be 15.0%. Of course, percent really means that that number is divided by 100. So that's how we're going to put it into this problem. So 15.0 divided by 100 is our percent. Our percent is equal to the mass of the solute divided by the mass of the solution. We are given that we have 900.0 grams of a brine solution. So that should be your key, that that's the number that goes into the denominator. So we have 900 grams of brine salt, which is saltwater solution. We are being asked to find what mass of water is needed, but from this problem right here, we have to solve for the mass of the solute. So hang with me for just a moment and I'll show you where we're going to go with this. Well, if you cross multiply and solve for x, you will find that x is equal to 135 grams. Now the mass of our solute in this problem is NaCl. Okay, that's our solute. In a brine solution, the solute would be sodium chloride and the solvent would be water. So the mass of our solute is 135 grams of NaCl, our solute. So now let's think about this overall problem. That's not what the question's asking. The question is asking for the mass of water that is needed. Well, the water is our solvent. So how are we going to find the mass of our solvent? Well, let's think about this. The solution contains both the solute and the solvent. So if we subtract out from the mass of the solution the mass of the solute, we should have the mass of the solvent. Okay, so the solution mass was 900.0 grams. The solute mass we just figured out was 135 grams. So if we subtract those two numbers, we get 765 grams of solvent, which in this case is water, because brine is a saltwater solution. All right, let's go back to problem number 2, where we're going to start to take a look at a couple of molarity questions. Molarity as a concentration expression tells us the number of moles of solute in the liters of solution. Question number 2 reads, well, before we get to the problem, let's rewrite this. Molarity is often abbreviated as M, capital M, and it is equal to moles, abbreviated MOL, per liter. So that's just an abbreviated way of writing the same equation. Okay. The problem reads, what is the molarity of a solution with a volume of 2.5 liters containing 660 grams of calcium phosphate, which has a molar mass of 310.3 grams per moles? So yes, I'm giving you the molar mass here. We are going to have to do a molar mass conversion. Let's take a moment here to take a look at our equation. Okay, molarity is going to be equal to the moles per liters. All right. What we need to plug in here, we are being asked to find the molarity. So we are being asked to find the molarity, which means we have to plug in a number for moles and a number for liters. We have the volume of the solution to be 2.5 liters. But what we need to plug in is the number of moles. But we weren't given moles, we were given 660 grams. So a little side calculation is necessary. 660 grams of calcium phosphate needs to be converted. Setting up our molar conversion, 1 mole of calcium phosphate is equal to 310.3 grams. So when we multiply 660 times 1 and divide that by 310.3, we get the number 2.126973896 moles, which of course has too many significant figures. Going back to 660, we see 2 significant figures, so we must round this number to have 2 significant figures, and that would result in 2.1 moles. Okay, but that's not really our answer. We have to take that number and plug it back up into this equation, 2.1 moles here. So 2.1 moles divided by 2.5 liters in your calculator comes out to be 0.84. Now, moles per liters is the actual unit here, but moles per liter is always abbreviated as a capital M. So that is the best way to write this. 0.84 molar is how you would read it, but that big M really stands for the units moles per liters. All right, let's take a look at some other molarity problems which are going to ask you to solve for the other things in that equation. Number 4, what volume of a 2.00 molar solution can be prepared using 0.750 moles of KNO3? Okay, the fact that they're giving us a molar solution, they're giving us volume, they're giving us moles, that's the key to use the molarity equation. So we're starting with molarity equals moles per liter. I'm going to rearrange this equation because what we're really trying to find is the volume. So to rearrange this equation to get liters all by itself, you know, really this is M over 1. So what we have here is moles equal to liters per, or liters times molarity. But then to get liters all by itself, we will have to divide by the molarity. So what we end up having is liters is going to be the number of moles divided by the molarity. Okay, so let's plug that back in, or I'm going to rewrite that. Liters is equal to moles divided by molarity. Just a little cleaner to do it over here. So what we have for the number of moles, 0.750 moles of KNO3, 0.750 moles. And we're going to divide that by the molarity of 2.00 moles. Or I'm sorry, 2.00 molar. Now, instead of putting an M here, because then you don't really think that any units are canceling, in reality that molar symbol is moles per liter. And then you can see that the moles will cancel, leaving you with a liters unit, which is what we are solving for. So plugging this into your calculator, you will see the answer come out very cleanly to be 0.375 liters. That's 3 significant figures, which is what all our measurements were to begin with, so there's no rounding necessary here. 0.375 liters, which of course would be 375 milliliters. All right, the next problem, we are going to be solving for moles of solute. How do I know that? Well, it says how many moles of cobalt chloride are needed to make 2.5 liters of a 1.0 molar solution. Right, I'm going to start with the original equation. Molarity equals moles per liters. We want to solve for moles, so cross multiplying, you would get moles is equal to liters times molarity, which is what we are solving for. There I see moles all by itself, so we're good to go for plug-in. So moles are equal to liters times molarity. We are given a volume of 2.50 liters. We are given a molarity of 1.08 molars. Remember, when we see the big M, what the unit really is moles per liter. So here we can see that liters will cancel, leaving us with the unit of moles, which is what we are trying to get. Now, in our calculators, 2.50 times 1.08, you get the answer 2.70 in your calculator. No roundings necessary. 3 sig figs is what we were shooting for anyway, so we're good to go on that. The last question is going to ask us to solve for the mass of the solute. Okay, if you're trying to find the mass of the solute, the first thing you're going to have to do is solve for moles and then convert to grams. So that's the strategy. We're going to have to start with moles. Now we've already seen that when we rearrange the molarity equation, moles is equal to liters times molarity. We are given a volume of 2.00 liters. We are given a molarity of 1.54 molar, which of course is moles per liter. Liters cancel, and in your calculator you get the answer 3.08 moles, giving you nice 3 significant figures, which is what we had to begin with, so no rounding is necessary. But that's not quite the answer we're looking for, because we're looking for mass. So we're going to have to take that moles answer and convert to grams. So moles will go in the denominator, grams will go in the numerator. 1 mole is equal to 44.0 grams for CO2, and of course I'm getting that number from the periodic table. I'm not going to review that concept now. Moles will cancel. 3.08 times 44.0, you get the answer 135.52 grams. We need to round that to 3 sig figs to reflect our measurements, and so this number would round to 136 grams of CO2. All right, that's it for the different types of problems for molarity and percent by mass that I will ask you to solve for. You should have an additional practice sheet so that you can try these problems and strategies on your own. We'll see you in the classroom.